Yes. So once again, very good morning to all of you. So today we will do this. We'll continue with our application layer protocols. So in the previous lecture, we have discussed about the HTTP protocol. So that's very, you can say, common application which we all of us means using since so many years, right? So how this web application works. So the HTTP protocol is used, and different variants or versions of the HTTP protocol we have discussed. Now, just one thing was left from that HTTP protocol. There's a recent development in 2015. The HTTP2 protocol, the new version of the HTTP protocol came, and this protocol is compared to the HTTP1 and HTTP 1.0 and 1.1. If we compare that, this protocol have a lot of features, and these features are related to the related to the performance, means how fast a HTTP page can be transferred. So because over the period of time, because HTTP was this protocol was uh, designed long back. After that, the web pages, the way the web pages works, that thing is also changed. Means very heavy, you can say heavy multimedia content is used in the web pages design. So I mean the performance is now a severe, you can say, problem or a requirement from the HTTP protocol, which was designed primarily earlier for uh, text, mostly text and images, but now a lot of other multimedia content is there. So we will just briefly discuss, not much detail, but yeah, to just understand that how HTTP2 is better in terms of the performance, downloading or accessing or retrieving a web page as compared to the HTTP1. So we'll start with that, spend 5-7 minutes on that. And then we'll switch to the another important protocol, which is the domain name system. So I think this term is very common, means those who are using internet and all, DNS entry or something we talk about. So what exactly this domain name system is there, what is its role, and uh, means how this DNS system has been implemented in the internet. So we'll talk about that. And then another common protocol which we all of us use for transferring the file or accessing the file from a remote location, FTP server. Sometime you might have received some URL which belongs to a FTP server. There you have to provide your username, password, and then you can download the files from there. So the underlying concept or the protocol which is used is the FTP, file transfer protocol. This protocol also have a lot of variants, but yeah, we'll talk about the basic FTP protocol and how this protocol basically enables the file transfer. So this is the agenda for the today's session. Okay, so come to the first part, that is HTTP2. I hope you remember the HTTP1, means how it works. Persistent, non-persistent. There are two variants of HTTP protocol. HTTP 1.1 is a persistent, so single TCP connection opened, and over that multiple objects of the web page are transferred. Right, that's a HTTP 1.1. So, uh, so just to see the what is before going to the difference, let us see that few. So we'll see for few differences. First difference is HTTP2 is a stream-oriented protocol, and that's why here it is written that a stream multiplexing. So it multiplexes the stream. So stream is what? The stream is, it's a stream we can define as a bidirectional sequence of text format frames sent over the HTTP2 protocol exchange between the server and the client. Right? So that is a stream. So then HTTP, if we say HTTP1 is capable of transmitting only one stream at a time. So if you suppose by a HTTP2 protocol, HTTP and HTTP1, persistent HTTP1, this is client and this is server. right? So initial connection establishment process is there. So it requires one RTT. I just wrote it here. So this is a TCP connection establishment. And after getting the first response from the server, in that client knows that how many objects are there. So with respect to each object, a separate GET request can be sent by the client, right? So if it is the first, so in a pipelined version of the HTTP 1.1, so this is HTTP 1.1, and I'm talking about pipelined. So in pipeline means without waiting for the previous object response of the previous request, the next request can be sent. So means in a single RTT, the multiple object request can be sent. Now, multiple requests can be sent, but the way the server responds sequentially only, sequentially or synchronously. So server response is, that's where this is very important. Server response in HTTP1 precisely 1.1 is in synchronous manner. So what do you mean by the synchronous? Or it means first object it will take, and let us say the first object, whatever the time it takes, means sometime it happens that object taking some time to read from the disk, or there may be some problem in the reading the means getting the value content of that. So then it cannot switch to the another, you can say, object. Or so first the entirely that first object will be processed by the server, HTTP server, that server side HTTP application, it processes that and then take on the second. So means this is something called as a head of line blocking. Means if the one object stuck due to some problem, then the next object also needs to face the delay, means that next object will be delayed. So in place of that, the better approach may be, so the response comes from the server is come in the order actually. So yeah, you want to say something? So HTTP2, how it is different? The HTTP2 is can respond. It can respond. Let me just a moment. Yeah. So it can respond asynchronously. Means HTTP2 can respond. HTTP2 means HTTP2 server. Okay, I'm sorry that space is less here. HTTP2 can respond asynchronously. Asynchronously. Now, what do you mean by the asynchronous? Means if the first object, it may be possible that okay, client is receiving first the first object, second object first. So second object is okay. Let me draw here. So suppose these are the request object requests are there, client to server. Then the second request may arrive first. Then the first request arrives. This way it can happen, right? So this means the server can respond asynchronously. So the stream which I'm talking about, in this stream, the multiple objects data can be mixed up, and so so basically each corresponding to each object there is a stream is there, and the frame which is constructed, that frame may contains data from the multiple streams. And now the receiving side of that HTTP2 protocol that will extract the individual object data, means that knows that how to extract, because in the frame, which is, I am not showing the frame structure here, but in that frame it can take out that okay, this so the in the one, you can say, a packet, you have a multiple frames, and one frame may belong to uh, object 1, another frame may belong to object 2, like that. So this is a multiplexing concept is used. So the overall result is that you can get the response, or client can receive the responses um, uh, in asynchronous manner, right? Or server can respond asynchronous manner Asynchronous manner means the objects can be transferred in a different order also, means not necessary that order in which the request is received in the same order it is processed. So this is the main, you can say, crux of HTTP2 protocol. Along with that, there are other features are also there. So I will few of the features I will talk about. So HTTP2 allows transmission of parallel multiplex requests and responses, and a binary framing layer is created, and this layer allows client and server to disintegrate the HTTP payload into the small, independent, manageable, interleaved sequence of frames. As I was talking about, that means small, you can say, frames are created, and these frames can belongs to the multiple objects, right? And that can be sent over the stream. So this information is then reassembled at the other end. So, and this HTTP2 is a binary protocol. It uses the binary information actually in the 1010. HTTP1 process the text information. So means because you know the transmission happens in binary, so binary to first the processing, binary to encoding is done into that text, and then the HTTP1 protocol works. But HTTP2 can directly work on the binary, so it is faster as compared to the HTTP1. You can visualize here that these are the HTTP2 streams example of. So client's side browser, let's say this is one image, this is another image, this is another image. So for each there is a stream is created, and a single TCP connection over that these multiple streams can be transferred, and the data can be multiplexed during the transmission. And because the client, the receiving side knows that how to disintegrate this data and how to means extract the data from the multiplex stream. So it has a sufficient information so that the data can be extracted from that for corresponding to each object. Apart from that, it has there is another good feature, that is a server push feature is there. So it allows the server to send additional cacheable information to the client that is not requested but anticipated in the future request. So again, it is a means because sometimes it happens that you requested a page and then there are maybe certain links that may be clicked or may not be, but in the anticipation that these links also will be clicked, so that information can also be sent along with the whatever the requested information. So certainly that data or that content will not be visible to the client until the client is not sending the request for that. So until that point, that content will be there in the cache of at the client side. And once the HTTP request will come from the client side, then first it will check in the cache. It is there in the cache, then it can be immediately provided from there. So that further means improve the performance, means the access delay can be reduced. So this mechanism saves the request respond round trip time and reduces the network latency. So better experience user get. That's obviously that in case if it is a client is not requesting, then okay, that whatever the data has been transferred and is available in the cache, okay, that's is not used, but okay, fine, means even is a 50% time also this cached information is used, then also you can see the significant improvement in the performance user experience. Okay, so this is so just we have a briefly discuss about that. So at least we know that yes, there is a newer version is there. And one last information I want to tell about this HTTP2 means actually this protocol work was started in 2009. There was a project which is SPDY project, and SPDY, you can say the successor, the predecessor of the HTTP2 is SPDY protocol, and then they modify the SPDY and formally this new protocol HTTP2 is introduced, and it is available in some of the browsers. Already it is incorporated, and it is means it is there. It's a practically it is been implemented. Maybe when you use the lab in the lab Wireshark, you will see maybe some HTTP2 protocol, HTTP2 packets are also captured if that from the source from where the packets you are capturing, if that web server or client is compatible with the HTTP2 web portion from the previous lecture. Now we are going to discuss the another important concept, you can say. So when you say that when a browser request, means when you type a URL in your browser client, browser is a HTTP client. When you type the URL, say for example bitspilani.ac.in index.html, the first get request is going. Means how this request so actually it is not like that. Okay, this URL is used as a destination, because this URL is the name of the host. It's a host name, and for the um, from the human being perspective, this name is convenient to remember or use it or type it, right, as compared to the some other identification. So that's why host names are uh, you can say identified with these URLs, which are very convenient for the human being to remember. But actually, machine means your computer is in order to send an HTTP request message to the destination host, which is in our case bitspilani.ac.in host. The client host must obtain the IP address of the destination host. IP address is a must. So it needs to get the IP address. So whichever the destination I'm looking, it's pilani.ac.in or amazon.com or yahoo.com or google.com or any other web service which I'm accessing, its IP address is a must. Right? And we are not, as a user, I'm not providing any IP address anywhere. And so now there are two things we need to understand. First thing is the question can come in your mind that, sir, why IP address? That name can go. The name is also, let us say, unique name is there, and we can access directly with that, or why uh, this name cannot be processed. So the thing is, these names, you know that you also familiar that names are variable size. Alphanumeric characters are used to construct a name of host, and it can be, I mean, a small name, big name, large name. There is no as such standard used. I mean, okay, uh, small and to big, it can be any number of characters. So now routers needs to, if routers are going to process these names, then that will be more complicated algorithms required to process the names, and based on that the forwarding will be done, as compared to some, you can say, fixed format identification. And that fixed format identification is something IP address, which looks like this. Suppose this is a IP address. So IP address, you know, this is IPv4 address example. So it's a 32-bit address. So each, you can say, so these 4 octets are separated by the dots. This is the way IP address. So it's a 32-bit. So if you convert into the binary, so 120 corresponding binary you can write. Okay, I'm writing just arbitrarily 8 bits. Okay, don't say that, okay, sir, it is wrong. So this is 8-bit. Then 10 will be 000001010. Again 10 is 000001010. 5 is 000000101. Okay, these are all correct, but yeah, this may be incorrect. Okay, so this kind of a 32 bits. So now routers need to process this, and there is a hierarchy in that. Means this these IP addresses are there is a hierarchy involved in that. We will don't worry right now. We will understand what this hierarchy is there, because networks are divided into subnetwork. Subnetwork can be further divided into sub-subnetwork and so on. So that hierarchy helps basically to you can say forward the um, you can say packets in such a way that okay um, it can reach to the destination. I will give an analogy for that. Like postal address you have, so you know how to read by looking at a postal address or pin code. With each digit, by processing the digit, it tells something that okay, yes, this is belongs to Rajasthan. Within Rajasthan, okay, this is belong to this city, and now this city, then okay, then they have within the city, then they just look at the address, which part of the address, maybe uh, the community name, or you can say within the community, you'll say that okay, which road or which locality and so on. So this way the address is processed in a hierarchical manner. Similarly, the IP address also have a hierarchy. Is in 32-bit itself, the hierarchy is hidden actually in that. So that is easy for the routers to process. That's why this IP address is must. Now the question is that if it is must, fine, okay, because alphanumeric thing processing is for routers it will be complicated as compared to just processing these numbers. Then we say um, from where this who is converting or from this host name to IP address, where it is converted, because as an end user I am not providing this information anywhere when I am accessing a web page, or when I am web browser I am using and accessing the web page. So to answer this, we need to understand this. There is a system which is domain name system. It's a name service which maps the name that is people use to locate a website. Name means this host name, right? To the IP address that a computer uses to locate a website. So uh, so why do we need the mapping between the host name and IP address? That I have already answered. That why do we need it? Because routers, for routers, it is easy to process the this fixed name as compared to the host name, fixed identification, that is IP address. Okay, so when you type this, then first this address means URL you type, and then there is a DNS query goes in the system from your system, and then through this domain name system the corresponding IP address is retrieved, and then that IP address is used to open the the TCP connection between the client host and the server host, and then your HTTP messages are transferred. Okay, so this DNS is basically a application layer protocol, and its main purpose is to resolve the names. Means host name is provided, it goes as an you can say kind of input, and or it goes as a request, and the response comes as a corresponding IP address. Now come to this, how this DNS naming. So if we say it's a kind of a directory system, suppose let us say I have 100 such host names are there. I just go with a very hypothetical scenario. 100 hosts are there, host names are there, right? bitspilani.se.in and like that, so many, that 100 are there. Now these 100 names I have stored somewhere in some server, okay, and the corresponding IP address is there. So what I have stored, host names I have stored, and the corresponding IP address I have stored, right? So now if from the client machine, the request will always go to this server with the host name. Say, okay, host name X, host name is there, the corresponding IP address is this. In the response to this query, this server can return, okay, this is the IP address, and then that IP address can be used for further to initiate the communication basically. Without that, even the communication cannot be initiated with the destination server. So it looks very simple, fine. Then there's nothing great in that, but you know that these host names are not 100 actually, means there are so many hosts are there, right? So a single server will be a problem. It's a bottleneck, a single point of failure, single point of bottleneck. So initially, actually, when the beginning, many years back, the service was deployed in this manner only. and as a one, because that time very few host names were there. But later on, immediately they realize that, okay, no, this is not going to work, because any update happens, then and then single server is not means become a performance bottleneck. So then they, okay, we'll distribute this. So now distribution again, then maintaining consistency is a problem. Means if any update happens, that update should go everywhere. So we need some structured way to store this information, and that structured way is something like this. So there's a hierarchy of the DNS servers or name servers. So these, because the servers which resolve the or which keeps the mapping of host name to IP address mapping, these servers we call as a name servers or domain name servers, right? So in this hierarchy, the very first top level, it is a root DNS servers, right? And then you have uh, the the second hierarchy is called a TLD, top level domain server, TLD, right? Top level domains, there are top level domains like .com, right? This is .org, and then this is .edu, like that. There are so many top level domains are there. Okay, so if you are interested to know that what are the top level domains are there available presently, so this is the URL. You can go and check it, that what are the top level domains presently there. TLD domain server, that entire list is available here. It is updated by the this internet organization, right? So now this top level, so root servers we'll see in the next slide, but root servers are basically 13 total root servers are there, 13 in number root servers are there. Okay, more on this we'll go to next slide. So means at a very basic level, we can say that how actually this mapping or this name resolution service works actually. So very at a basic level, right? First to understand just. So let us say client wants IP of some www.amazon.com. So the client queries the root server to find the .com DNS server. Means first the request will go to the root server, one of the root servers. 13 root servers are there. So request will go to the one of the root server. Now that root server basically maintain the information of all the top level domains, right? So then it will just look at that, okay, request is coming for .com. So then it will reply to the client that this server is responsible for the you can say for .com. Then the client will query to the .com DNS server, means who is maintaining where the .com domain mapping is maintained. So query the DNS server to get the Amazon.com DNS server. Then this .com, that is a top level domain, that forward the query to, in this case, it will forward the query to this Amazon.com DNS server. Means all the Amazon domain names in which the Amazon comes, that name, right? So suppose abc.amazon.com, right? Then xyz.amazon.com. For all such domain names, this server is a responsible, right? And we call this as a authoritative DNS server. So the third level in this hierarchy, authoritative DNS server. So this is authoritative, this is top level domain, this is a root. So this is a 3-level hierarchy is there. Finally, because authoritative means, as name suggests, that okay, means obviously at this server that IP address of the requested host name is there, that ensures that, because that's why it's authoritative. So the client queries to Amazon.com DNS server to get the IP address for the www.amazon.com, and then the HTTP request will be sent from the server, sorry, client to the server, and so this is a at a very basic level, this is the process, right? So now come to this root server. As I said, is a total 13 servers are there, and mostly located in the North America. And each actually 13, and their names are, you can say in this picture, you can say the names are given by English first 13 letters of the these alphabets. Okay, 1 to 13, A to M. And actually it's not just a single server. Okay, I hope you understand that it's not just on a one each. So if I say e-server is just a one physical server. No, it's a each server is actually a network of replicated server. And for the two reasons, this network, one is that load amount of load, because otherwise just one physical server will be become a single point of a bottleneck. Also from the security and the reliability point of view, if one fails, then entire information will be lost and the world will be not able to reach, not able, this name resolving service will not work, then most of the you can say internet traffic will be affected. So you need some kind of a replication to get the reliability and all. Um, Other than so far we understand a host name and corresponding IP address. A host name goes as a request to the DNS system, and then the response comes as a corresponding IP address. Okay, so this is a one thing, but there are other services are also there. So host name to IP address translation anyway it does. Then host aliasing also we can do actually. That also is supported by the DNS. Aliasing is something like that. We call we give the different names to our website, and then these names can be mapped. So let us say we have uh, bits pilani www.bits-pilani.se.in. That's the one name. Then we have discovery.bits-pilani.se.in. So like that we can give multiple names, right? So usually the original names are usually very lengthy, means when we specify certain things, then the name which we want to give to the means our customers or the clients, which is publicly available, say okay how you can reach to me, that name should be very small, right? So for that we can create the alias names. Like you people, we also, a human being also have the home, one is the name which is we have in our records, right? Another name which with the friends are calling, maybe, and your parents are calling with a different name. So these are aliases basically. Okay. So then mail server aliasing. So mail server aliasing service is again mapping service, host name to the mail server mapping. So like google.com have the mail servers also. The google.com and corresponding mail server mapping can be stored. So whenever a mail Gmail is accessed, then means mail service is accessed. So then the corresponding mail server, you can say IP address can be returned, right? Then it also does the load distribution. So means uh, so suppose for a given host name, for a given host name, uh, 4 IP addresses are stored, right? So one host name and corresponding 4 IP addresses are there. IP address 1, IP address 2, IP address 3, and 4. Right. So when the request come for that host name, so my DNS system is sometime it is returning this IP address as a, and assuming that okay, the service is replicated on all these servers, right? It's a distributed. That's why replicated web service. So this is for the reducing, you can say doing some kind of a load distribution. So for that purpose, this DNS system also can be used. So one host name, and that host name is queried by any client, then based on some load balancing algorithm, maybe round robin basis, or maybe based on the geographical location basis. Sometime this first IP address is returned, sometime second server IP address is third time, fourth, like that. So your load is distributed across the multiple web servers, and end user don't have to worry about that. Okay, to which server I need to contact, which is currently less loaded. So automatically the DNS service will decide. It is this logic is implemented at the DNS level that okay, how the load is going to be distributed among the multiple replicated servers, right? So this that also can be used. That also can be given by the DNS. So now in this slide, we will understand that how the DNS query is actually processed. The very first basic level, the query processing, we have seen that okay, client request first goes to the root server, and root means give the top level domain who is responsible for that domain. Then top level domain is contacted by the client, and then the top level, from there it gets the authoritative name server, right? And authoritative name server, obviously when we are means creating any new domain, then this is the place where we need to store the mapping. I will give you one example that how the records, DNS records are inserted into these uh, different DNS servers, right? Right now we are uh, understanding the retrieving of that information, right? So because we are, the way we are retrieving means in the similar fashion, the information needs to be first uh, add or store into the DNS servers. So here in this example, we'll see. So you can see here, this is a requesting host, and this requesting host is cis.poly.edu. Okay. And what it is requesting for, let us say, this server, which is gaia.cs.umass.edu, right? So, yeah. So the first from the client, the request will DNS request will go to the local DNS server. Now you will say, sir, from where this local DNS server has come? You told that okay, there is a root DNS server, then there is a TLD DNS server, and then authoritative DNS server. Now you all of a sudden you bring this DNS server, local DNS server. Okay, so actually when we say hierarchy, so the standard hierarchy is a root DNS server, TLD server, and the authoritative DNS server. Local DNS server is not necessarily that okay, it is always present, but mostly it is present in practice, uh, which is can be there in the organization. Like in our BITS PILANI campus, we have a local DNS server. So the first, from any host, any client host, the query DNS query will go to the local DNS server, right? And if the local DNS server have the mapping information, then local DNS server immediately reply to that, right? So that's the benefit. Actually, it's a kind of a caching, right? If the local DNS server don't have, then that request, so then on behalf of this requested client, this local DNS server will send the request to the root DNS server. Now you know the root DNS server A to M, total 13 root DNS servers are there. So this root DNS server, so that is known, right? So in your, you can say TCP/IP protocol stack, which is there in your operating system. So this information is already there. Okay, where this A2Ms, how to contact any of the root servers. So that information is already there in, you can say, client side of DNS application, right? So this request is going to one of the root server. Now root server is uh, that request it is forwarding to based on, so this request is corresponding to edu. So it say okay, now I don't know, okay, so I am forwarding this request to the TLD DNS server which belongs to edu, which is responsible for maintaining the information of edu, right? So it is going to top level domain server, right? And then the TLD will further send, TLD have the information about the authoritative, who is the authoritative server for the edu domain. So it sends to the edu, this server dns.cs.umass.edu, and this, from this server have the response. So it will send the response to the TLD. TLD will send to the root DNS server, and root DNS server will send to the local DNS server, and then local will send to the client host. This, so you can see total 8 messages have been exchanged, and in this manner, if the DNS query is processed, we call this as a recursive query processing. Okay, so recursive, you understood that? Okay, it means the nature, by the way the messages have been exchanged between among the DNS servers is that in a recursive manner, right? So theoretically, so there is iterative version is also there. So iterative and recursive, these are the two, you can say, ways through that the DNS query can be processed. Here I want to mention one more thing, and that thing is what? So it is not necessary that okay, TLD directly TLD have the information of authoritative DNS server. There may be an intermediate server between the TLD and the authoritative DNS server, right? So then So that may be that, okay, this there may be one server in between, and that server is so that server is basically, what is this server? It says it's a DNS dot umass dot edu. So when this TLD will see that, okay, it's this request is belongs to umass.edu. So this will, it will send this request to means it will forward the request to this server first. Now this server is the, you can say, authoritative server. This server have the authoritative server information for this domain. So this will send to this. So then one more, you can say, hop will be created and additional message will be there. So that is also means in some cases directly TLD don't have the authoritative servers information. So there may be intermediate another server is there, and that server have the actually the authoritative DNS server information, right? So, as I said, that largely that hierarchy is root and TLD and authoritative, but yeah, in practice, as the number of, you can say, domains are increasing, and then to reduce the load, in this hierarchy, few more layers have been created. Now we'll see that more so this recursive query, you see that, okay, this recursive query is not efficient in the sense because it is creating load on these servers, TLD means, and the root servers. So in this case, what happened? Each request, DNS request, these root servers are involved in that request, processing of that request, right? Means they need to maintain so many requests which are coming. So then the root servers maximum load will get, right? Because every request will go to the root server, and then the root server needs to be involved in this till this request is not completed, right? So this recursive manner is not the recursive choice is not good actually in that terms. So the practical, how the practically in the internet the DNS queries are processed. So we'll see this one. So from the client, the request is going to the local DNS server, and from the local, it send the root DNS server, right? And then the root DNS server will reply back. See, it gives the information about the TLD server, which TLD server is responsible, right? So then the local will communicate to the TLD server. Give me the IP address of this gaics.umass.edu. Then this TLD will say that, okay, I know I don't know the IP address of this, but I have the information of who is the authoritative DNS server, right? So authoritative DNS server information it will supply to client. See this local DNS server. Then the local DNS server will contact to authoritative DNS server, and then authoritative will finally reply, and that reply it will go to the, it will forward to the client. So in this process, what is happening means the involvement of root DNS server and top level domain server is reduced actually, right? And these servers are basically, they are means more loaded server as compared to authoritative. Maybe okay, it is just authoritative for a certain domain only. So number of request, amount of request which is going to be processed by this server will be less as compared to the top level domain. So top level domain, if you say edu, so now edu is handling all edu domains. So edu domains, maybe there may be tens of thousands of edu domains are there, right? So because within edu further bifurcation, like UMass is there, maybe it can be some Berkeley edu there. So many you can say subdomains are there in that. So to reduce the load on these servers, root server and particularly the TLD server, we need to this iterative query processing is more practical, which is used. One catch is there. Uh, this query processing at a local server is a recursive. So basically, if this practical DNS query processing we'll see, it is a combination of recursive and iterative. So this place, you can say this part is recursive basically. This is recursive, and these are the iterative. correct? So it's a combination of recursive and iterative. So this I already explained that, okay, the TLD server may just know only of an intermediate DNS server for host name, which in turn knows the authoritative DNS server, right? So in that case, actually I explained here now. So this one, so this separate one more, you can say, node will be there. Okay, so till this point, any doubt, any query, any quick question? So far we have not gone into the the details of the we are just details of the DNS protocol. We have just look at the how functionality wise how it is working, right? But inner details we have not discussed. We'll go in a so our next in 5 minutes I will explain that part as well. So any
Sir,
quick question? Yeah.
like let us say that on the server side we have an application which uses let's say 100 requests to a certain host, right?
Hmm,
So
hmm.
for every request it makes, it would have to go to the DNS server to resolve the IP address and then come back, right? So
Right.
would that add an overhead, and can that be resolved if we directly use the IP address of the a server that we are requesting?
First of all, how you will use the directly address, because the interface through which you are supplying this information, that interface doesn't allow you to the directly. So if suppose you are typing URL, okay, yes, I mean sometime in place of URL you IP address, but this is not practical now, because IP address anyway you will use it. But how many such websites IP address you know that? And
Like,
how do you know that, okay, that IP address might have been changed?
yeah, but
है ना?
if we are working in the on the server side, then mostly let us say that I have a server, I have two
Hmm,
servers, and the second
hmm.
server's IP address and the first server's IP address both are fixed. So the first server would know the second server's IP address, no?
What is first server and second server here?
The first server would be the main server that is interfacing with the clients, and the second server, which is basically being used by the first server to process some information. So the
Hmm.
IP address of both the servers is fixed, so I would know the IP address in advance.
No, that I know means basically this is you're talking about a one web service like that. There are so many web services are there, na?
Yeah, yeah. But on the
So
like on. Hmm.
how the each client will come to know. Okay, so to your worry is basically that, okay, there are so many requests are going. So for that, actually this is a good point. So there is a concept of DNS caching. There is a
Okay.
concept of DNS caching. So you see that if, say for example, first time very this local server, if you just look at this local server, first time this client have requested about the IP address of this server. Now there may be another client is there in this organization, right? Suppose, and then this the same that client is also accessing the same host server host. Then according as we know that, okay, this request will go through this all DNS systems, but that can be avoided by allowing the DNS responses caching at a local DNS server. So here the caching can be there. So the way the web proxy is used for reducing the outgoing traffic which is going from your organization to outside, similarly the local DNS, that caching can be done. And then next request that will come from another client or maybe the same client, that request can be satisfied from here itself. So then this entire load on this entire DNS, you can say, system is reduced. Like that. Now, what it can cache? Let us say this, it can cache the means we'll say this IP address of that. Maybe it can cache the TLD, which TLD is response. So TLD response it can cache. So at least it will, when another client will access the same host, then it will not send the request to the root server. Directly it will contact to the TLD. Okay, sorry, TLD response it is cached, so it will directly send to the authoritative, right?
Right.
But in this caching process there is a one catch. Means if any time for any server that mapping is changed, even the authoritatives also sometimes change. Maybe that IP address of that server there, because they have changed the service provider, so their IP address is changed. Then the cached information, with the help of the cached information, you will not able to connect to that server. So that caching needs to be for a some time only. Usually DNS caching is done for 1 to 2 days. After that, it automatically this information is removed from the caches, and then the request will all the way go to the main, whatever the process is there from the root server TLD. So that is in the view of that, if in case any changes happen, usually means it is not like the very frequently minute to minute this mapping can change, right? It's very but yeah, 1 or 2 day is through the you can say experience, it is found that 1 or 2 days is good enough, and that also reduced a decent amount of you can say load on the DNS system, and ultimately the user will get a response faster, right? Because immediately if this DNS query satisfied the local server, then your complete you can say end-to-end um retrieval also will be faster, because DNS query response is one component of that end-to-end uh, retrieval process.
Okay, got
Okay.
it. Yeah.
Yeah. So, and that caching can be used on local also. That TLD also can caches, let us say, authoritative servers names. So when, and suppose local is caching the TLD, so it will so local is means which is the top level domain. So local is contacting the TLD. Now TLD without TLD can give the um, yeah sorry sorry, this root server also can cache the TLD, so it can give the TLD, or it can, so basically, okay, I'm sorry, this root server basically not used for the caching, means root server always maintain the information of top level domain only, means they are not supposed to cache. Suppose in the recursive way, you may think of that, okay, can root server can cache the authoritative or authoritative, particularly request which response which is coming from authoritative, but that's uh, that is not done. The reason for that is because root server is all anyway it's heavily loaded, so no caching is applied. Caching is usually applied at a local DNS server or at the TLD server, right? So I think we are. I just tell you that these records, 4 records, and then I think next part will continue in the next class. So DNS. So now we are going to in some means inner details of that. So basically, this what request and response and what it contains information. So the DNS information which is stored on the servers, DNS servers, which is that is called is a resource records. And this resource record format is like this: 4-tuple information is there: name, value, type, and TTL. Name. So we'll take one by one. What is type? Type can be there are 4 types of records can be there. A type record. So A type record provides the mapping of host name to IP address. Means you give the host name and the corresponding IP address is you will get it from the A record, right? And TTL says that how long that information is valid actually. So for the caching purpose, when you cache, then okay, the TTL is stored along with that. Okay, how long that information is valid. This record, this resource record is valid. Okay, then the another record is NS type record. NS means the name system record. So in this, what is the name? Name is the domain. Like foo.com, and value is the host name of the authoritative name server, right? So domain name to who for this domain name, which is the authoritative name server, that mapping is stored in the NS record. So NS record contains the mapping of domain name to authoritative name server mapping. And third record type is the CNAME. CNAME stands for the canonical name. Canonical. Canonical is kind of a real name, right? Usually, as I said, real names are bigger names. So it keeps the mapping of the canonical name to alias names. Alias, so like IBM.com is canonical name is something server is.backup2.ibm.com. So this looks very long name, so it's not so for use it is good if you provide a more simpler name to the users to access this service. So you then IBM.com, but these two, but actual server name is this. So a alias name is created and the corresponding mapping is stored in the CNAME. Like that, you can create a multiple aliases. Then one more type of record is MX. There are other these are the four means you can say records. There are other records are also there. PTR record and some other records are also there. But we'll just for our understanding, I think we'll do this 4 records only. MX is for the mail server aliasing. So for in MX record, value is the name of mail server. So in place of value, the name of the mail server will be there, and name is the corresponding host name. So like google.com, so name will come as a google.com, and value will be the mail server name of the google.com. So that may be, let us say, for example, mail server 1.google.com. So this will be the value, and type will be MX, and TTL will be how long that record can be cached. So these are the 4 records are there. Okay, so I think means now its time is over, so we will continue with this discussion in the next class. So this is a DNS message format is there, right?
Sir, I had a doubt. Can I ask it now?
Please.
Sir,
Please,
can you go to the previous slide, sir? Slide number 12.